The previous session, as a preview, I wanted you to look at, encourage you to look at this app that deals with dot product, and I've reopened it here. Let's go back to the slides. Notice that the angle between the two vectors gets close to 90 degrees, or pi over 2 radians, when the dot product of the two vectors is close to 0. So let's just give it a try, right? So I'd like to try to get the result of the dot product, currently negative 4.5 here. Let me change the vector u, and I'd like to get that number to get close to 0. I am real close right now, negative 0.06. And if you look at that angle, 90.12 degrees, right? So maybe, let's see, where do I need to move this so that I can get a better shot at 0 as the value of the dot product? So that looks even better. Oh, whoops, moving my mouse a little too quick. So 90.03 degrees as the angle between the two position vectors, and negative 0.02 for the value of the dot product. This should all work out the same. If I just, I don't know, take the next one, take the other vector, I could move it around as well. Let's create another 90 degree angle. Let's all go at 80, so let's see. Somewhere, how about there? Like 89.51 degrees, and the dot product is 0.5, right? So, yeah, let's see. Oh, I don't have as much room as I guess I'll have to scroll down here. Oh, there we go. So the dot product value is 0.04, and then the angle is 89.97 degrees. That's fairly good. So it appears anyway to be the case that 90 degree angle between the two vectors you make should correspond to 0 value for the dot product. Okay. So this app is only for 2D vectors, but really the same phenomenon occurs in 3D vectors. So it's harder to obviously draw all of this stuff in three-dimensional space, but we have the following theorem which ends up being true. So let's use theta to denote the angle between two given vectors A and B. So that angle theta is pi over 2 radians if and only if the dot product of the two vectors is the 0 scalar. So using the app linked above, I would ask you to explore, given two vectors A and B, what do you conjecture must be true about A dot B for the angle theta between the two vectors to be acute? And what do you conjecture must be true for the dot product in order for the angle between the two vectors to be obtuse? Okay, as a definition, the vectors u and w are orthogonal if the angle between the two vectors is pi over 2. And if you'd like, you can replace the word orthogonal with perpendicular. These two words are going to be synonymous for me. Okay. So I've got a vector 2, 2, negative 1, and a vector 5, negative 4, 2. I would have a hard time drawing these vectors in two-dimensional space. I mean, I could, but could I draw them accurately enough to be able to tell, are these two vectors going to form, are these two arrows, once properly drawn, going to form a 90-degree angle? I could not do this problem geometrically, to be honest. There's just no way I could get an assurance that we would have exactly 90 degrees. I mean, how can I draw the picture good enough? Right? So instead, we run it through this theorem. I compute the dot product of the two vectors. I got 0 as the scalar here. So in fact, these two vectors are perfectly orthogonal. They make a perfect 90-degree angle to each other. Right? This is fantastic. So without having to draw, we concluded that two vectors form a right angle based on getting 0 as the value of the dot product, getting that scalar of 0. See, this is what I'm trying to get at with when I say the phrase drawing without drawing. Right? I can visualize. I could even go ahead and actually attempt to draw a rough sketch of this vector and that vector, both as position vectors. But should I, even from my drawing, get any sense of whether the vectors truly are orthogonal or not? I think I could, in some extreme case, maybe convince myself, oh, these two vectors, they're pointing nearly in opposite directions, so they're probably not going to be orthogonal. But if I had anything that even closely resembled like a chance of being a 90-degree angle, if I wanted to know for sure, I wouldn't. But this dot product thing, I mean, not by drawing anyway, but this dot product formula and this angle that we're seeing, it's really doing the trick for us. This is drawing without drawing.